Hello dear students, in this lesson we start learning creational patterns. In previous lesson we already performed an overview of creational, structural and behavioral patterns. Now it is time to learn patterns from each group one by one, and we'll start from creational patterns. That's why in this lesson we'll dive into the specifics of each creational pattern. In our plans to review today Singleton, Prototype, Factory Method, Builder and Abstract Factory pattern. Especially for this lesson, I prepared code examples that will help you to understand and learn these patterns faster. Let's start. And the first pattern is Singleton. We'll review each pattern in the similar format. The first thing that we'll learn for each pattern is its intent and what problem we are going to address with this pattern. Intent of the Singleton pattern is to ensure a class has only one instance and provide a global point of access to it. But what problem we'll address in case we'll have only one instance of object in our app? In some cases, we don't need to create a new instance of the class each time we need. Imagine simple example. You have type called Order Management Service. The object of this class can place order, and you really don't need to create multiple objects of the same type, because actually you don't need it. What you need is just a behavior of placing order. And this behavior can be executed by one single object in your application during the runtime. We are going to save a little bit memory in Java heap by not creating new object each new time we need it. We know that Java has automated memory management, and we can find garbage collector in Java too. But in case we'll create millions of such objects that we just use only one time and that's it, we will wake up garbage collector and this can reduce performance a little bit and temporarily. So in this case, I just wanna be sure that I don't need to make garbage collector work by creating a lot of objects in memory. Now, when we understood the goal of Singleton pattern, let's jump to the example and we'll look at the implementation. So here we have Order Management Service class. The first thing that we need to do if we wanted to implement Singleton pattern is to declare a private static field of the same type. This field will hold the reference to the single instance of the type. The second thing that we need to do is to create a private constructor. We need to make constructor private so that no one would be able to get access to it and call this constructor outside of this class. This allows us to restrict object instantiation outside of this class. The third thing that we should do, we need to declare a public static function. We'll call it accessor function that will allow end users to access our object when it will be needed. Pay attention that this function should be public and we will invoke it with the help of the class, taking into account we won't be able to create an instance of a class. Also, I will implement lazy initialization inside this accessor function. What does lazy initialization mean? This means that I initialize object not when program is started, but I initialize the object on request when it is first called. Here in method you can see that I perform check, and if our static field is null, then I initialize object. In both cases I return the reference to the same object all times. To avoid very edge case of creation of two objects from different threads of execution, I also add synchronized keyword to this method to make sure that only one thread of execution will be able to enter this method body simultaneously. And after that you can declare any non-static behavior of this type. So any methods you would like to create, feel free to do it. You will be able to call these methods on this object. I will add one method, place order, just an example here. Basically, that's it. Let me now open demo file and show you how we can use Singleton pattern. I'm running this file to explore console output with you. I can create two references and initialize them with Order Management Service object. And when I compare it with equals operator, I get true because in both cases I get the reference to the same object. And you can initialize any field of Order Management Service type in your program like this, and be sure that you have only one object of the current type in the memory. You can see here that taking into account our constructor is private, I can't invoke constructor. And once we get reference to object of our type, we can call any other methods of this object. So here I can call placeOrder method, for example, and we can see in console output that this method was invoked on the object. Hopefully now it is clear for you how to implement singleton pattern. Now let's discuss few things. It is worth to mention that sometimes you can find in the internet that singleton pattern is pure evil, and somebody even treat it as an anti-pattern and telling us that is something what we never should do. I recommend you to be professional and don't fall in the false argument. Let's try to understand why some people hate singleton pattern. First of all, I would like to say that in case this pattern wouldn't be needed, it would just don't exist. But it exists for a reason. So each pattern comes with pros and cons, and we just should be aware about those rather than stating that this pattern is bad. Each pattern is good for a specific case. The first thing that haters of singleton pattern is mentioning is that this specific implementation violates single responsibility principle. So at this moment, our order management service is responsible for both managing his own life cycle and order management. But how critical it is? I would say that taking into account his first responsibility we have mentioned, managing life cycle, doesn't depend on other units, and it is very little chances that this responsibility become a separate reason to change. And also, when we will learn frameworks for enterprise Java, for example EJB, that stands for Enterprise Java Beans, or Spring Framework, we will discover that these technologies describe so-called containers that manage lifecycle of all instances in the app. In Spring, default scope of all beans is singleton. In this case, responsibility for managing lifecycle is transferred to Spring, and that is fine. But what to do in case you need singleton and you don't have such container like in Spring or in EJB? So this point is discussable. The second thing why some people hate singleton is about static nature inside its implementation. And you know what? Sometimes people just hating things without getting deeper understanding of what actually wrong and what is the impact. The true impact of static nature inside singleton will impact us in case our class shares some state. So imagine in case our order management service would have some fields, and methods would modify the state of this object. And taking into account we have only one instance of this type, we're constantly changing its state and impacting calculations in other parts of our program. And this is really a true issue. But we shouldn't implement singleton pattern for types that should have some state. Remember, it is very hard to catch defects in case our singleton doesn't have fields and any state. Such types of objects are called stateless. And in case object is stateless, you shouldn't face with any negative consequences of singleton. And the third thing that some people is concerning about is impact during the testing of singleton. But I would say that this is potential impact of some static nature inside this singleton. Because in case you wanna create multiple unit tests and run them one after another, you should come up with a mechanism that resets the state of the object under test, because you won't be able to create another instance during the test like you usually do in unit testing. So, as you can see, the singleton pattern is not so bad as somebody can imagine. And to summarize our talks around singleton pattern, I want to simplify your life, and that's why I made a simple checklist to follow in case you want to implement singleton pattern. Here it is. Define a private static field in the singleton class. Make constructor private. Implement public accessor function. Implement lazy initialization, that is creation on first use, inside the accessor function. Make sure that accessor function is synchronized in case it is going to be used in multi-threading environment. I think that's it about singleton. Let's learn new pattern now. And the next pattern from our list is a prototype pattern. What is the intention of this pattern? Prototype is supposed to simplify project instantiation process by providing us with prototypes to create complex objects faster without new keyword. Because sometimes composing new object can take a lot of lines of code and specific domain knowledge of the system how to construct object. Multiply this by amount of times you create new objects of such type in your system, and you will come up with the idea to create object by cloning prototype. That should be easier. Imagine the real-life example. You have some file on your computer that you want to copy to another directory. You press Ctrl and C to copy file to a clipboard, to paste it in another directory later. That is just one of real-life examples that demonstrates when you might need to create a new object based on another one. Inside your code, you can clone any object like this to create its copy. Let's look at the demo to understand this pattern better. And to understand example on Java, make sure that you are familiar with cloning objects concept in Java. Because from technical standpoint, implementation of prototype depends on implementation of deep cloning for specific object. Let me show you an example. Imagine that I have archiver interface. This type describes contract for all kinds of archivers in my app that I am going to use to archive files. This type declares two methods, archive method itself and clone method. We will implement deep cloning in all implementations of archiver type. I hope that archiver interface looks clear for you. Let's jump to implementations. We have two implementations, zip archiver and rar archiver. Each implements archive method. It is just a stub here for the sake of example, an implementation of clone method. If you know how cloning in Java works, you understand that clone method from object class makes shallow cloning. That means clone only references, but not actually cloning the whole graph of objects that stands behind the references inside the class. I mean its state that is described in fields. So always keep in mind that no matter what programming language you use, you should implement deep cloning of object to provide external interface to clone it, thereby implement prototype pattern. And to easily implement deep cloning, I use out-of-the-box method of serialization utils from Apache Command Slang library. It also requires make my type serializable. In case you are interested in serialization, feel free to check my lesson from Java course about serialization. Now when we have implementation to clone, let's think for a second. How user will interact with our prototypes? How to provide clients of our code with comfortable interface to create objects from our prototypes? There are different ways to address this question. I will show you just one of the possible solutions that I hope will work for you in your specific case. I create archiver factory. This is class that can generate objects of different types that are compatible with archiver interface. Archiver factory has prototypes map, and in static initialization block, I just add different objects that will be used as original objects to clone, mapped with some string. Also, the factory introduced public static method called getPrototype for a type that takes string as an argument and returns clone of our prototype based on the requested archiver type. Does it make sense? Pause the video for a second and think about this solution. I believe that this is a very elegant solution of the problem. And when it comes to actually using the prototypes, you can use archiver factory like this. Imagine that at a runtime you have requests for different archivers, and you have two strings, zip and rar. You just use archiver factory and request archiver from it, to call archive method on received object. Let me execute the program. So, as you can see, during the runtime I get new clones based on my prototypes and they worked just perfect. Hope that this complete example helps you to understand how prototype pattern is implemented. Let's look through the checklist that you will use when you will implement a prototype pattern. The first item in our list is to add clone method to the hierarchy of our objects. The next thing would be to design a registry that maintains a cache of prototypical objects. That is exactly the moment when we created factory class in our example with original prototypical objects in it, remember? Next, design API that allows to clone object inside the factory and return new object as a result. Use factory API instead of new keyword to instantiate the objects. That's it. Let's move on. The next pattern is a factory method. The idea of factory method is to define an interface to create object, but let subclasses decide what concrete object to choose and what actual class to instantiate. We need factory method in cases when we need to standardize the architectural model for a range of applications. But each application decides what object is to instantiate. And this example is just one of possible examples where factory method is applicable. In real life, you will see that we are going to use factory method also in other patterns, such as AppSec factory. People often use factory method as the standard way to create objects, but it isn't necessary if the class that instantiated never changes, or instantiation takes place in an operation that subclasses can easily override, such as an initialization operation. Let's look at example to understand how it works. And to help you understand this pattern, we'll use previous example with archivers. So here is archiver interface from the previous example. We don't need clone method anymore, since I'm going to show you factory method pattern. We have the same implementation of archiver interface. We have zip and rar archiver. And our archiver factory is different. I have method here getArchiver, and this method returns me different objects of archiver interface based on the string that I passed to it. How exactly it does it? I also wanna say that you will find different variations of such pattern. In some examples you will see that there are multiple if-else blocks here to call constructor to instantiate specific type. In some examples I even saw switch block. That is not the best decision, taking into account you are going to have long and unreadable if-else statement in case you will have a lot of different implementations. And also this approach will require you to update the source code. Approach that I suggest here takes less lines of code and easily customizable in case you use some IoT container, like Spring container that will produce new beans for you on a request. In that case, I would be able easily reuse this solution and add new types by adjusting configuration XML file. In my solution, I create a map with archiver type string and function that generates new object of this specific type. What is this function? This is a constructor. And you know that function that takes nothing but returns something in Java called supplier. If you don't remember that, feel free to check functional programming section of my Java course. And in static initialization block, I map type strings with constructors with the help of method references. Great! And now I use ternary operator to implement getArchiver method. In case I can't find such mapping in map, I return null. In case there is some mapping, I execute this function. And by interface contract, in suppliers we have get method. That's why I called it here. Let's look at demo class now. I just use factory method to instantiate two objects. I run the program. And you can see in console we have different outputs produced by two different objects. Also, to prove you that factory generates new objects each time, I generated one more zip archive and compared it with existing one with equals operator. And you can see in console that the result is false. That means these two references are pointing out to different objects in heap memory. Does it make sense? In case you still have some questions, let me know by asking it in comments to this video. Now let's recap factory pattern and create a checklist for its implementation in the future. The first thing we need to do is to define a hierarchy of objects. As you can see, factory method use inheritance mechanism to provide you with the object of type that you need. The next thing to do is to design the arguments to the factory method. Think about qualities or characteristics that are necessary and sufficient to identify the correct derived class to instantiate. In our specific example, we used only string with archiver name, but actually it can be a set of arguments. Call factory method during the runtime to instantiate the object that you need. Great! We're already done with 3 creational patterns. 2 more patterns from this group left. The next pattern that we are going to learn is builder pattern. Why we might need builder pattern? Imagine that you have complex object to build and you wanna come up with the API that will allow you easily to define what exact version of object you would like to construct. In other words, imagine the case when an application needs to create the elements of a complex aggregate. And the interesting thing about builder is that you can find different variations of the builder pattern that actually solve our original problem, but implemented in different ways. For example, there is a variation of pattern with director class that is responsible for building objects, and also there is a variation of builder pattern that's called chain builder and allows to build new objects step by step. Personally, I believe that the second variation is more popular, but I want to share with you all variations with examples. We'll start from builder pattern implementation with director. Imagine that you need to build a computer, and you have computer class and you know all properties of computer. Let's look at it. So simple computer class that has display, system block, and manipulators. We have computer builder type. Here it is. It has computer property, abstract methods to build each property of a computer, create new computer method, and get computer method that returns the reference to the current computer field. I believe you understood already that we need to create concrete builders that will implement these abstract methods. In our example, we have cheap computer builder and expensive computer builder. The main things that you have to understand here is that these build methods change state of our computer object. Taking into account these are child classes of my abstract computer builder, I have access to computer property inside this class too. Taking into account in our example computer has only string properties, I just set different strings. But in real life, all construction logic of each field will be placed here. Okay, now when we have different computer builders, we need to have a director that knows how to organize work of builders to produce expected result. We have computer director class here. As you can see, it aggregates computer builder inside, and this builder we can pass to the constructor. We have build computer method, where I build computer by delegating work to my builder, and after that I can provide build computer on a separate request. I'm talking about getComputer method. This architecture allows me to substitute builder on the fly and build new computer based on the other builder, or build series of the same computers without passing the same data multiple times either to constructor of computer class or to setters. Does it make sense so far? Press a pause for a minute to understand how these classes are connected. And by the way, you will find references to the source code of all examples in attachments to this lesson. It is just a regular Git repository, so you can basically just pull repository on your local computer and investigate the source code. Let's continue. Here is the client of our code, and here you can see how builder pattern will work. I create director, and based on the current needs, I can set different builder. After that, I build computer and retrieve computer from director. That's it. So much preparations were done to achieve this simplicity in building complex objects and being able to change building logic on the fly. And here you can see that I set new builder, expensive computer builder this time, and built new computer and printing it again to console. Let me run this program. And in console output you can see that we managed to build different computers, cheap and expensive one. Is it clear? Hope that this version of builder pattern is clear. Let's review another version of builder pattern, chain builder. The idea here is simple. We have a class that has builder inside it that knows how to build the object. Each method of the builder returns the reference to builder object to call next method in chain-like style. Taking into account builder is an inner class, it has access to all fields from outer class. Here is static new builder method that creates builder based on the account object. Here is the inner class builder. It has private constructor so that nobody from the outside could create a builder object. And after that we have setters methods that initialize the state of our account object, and each time setters returns the reference to the current object, the current builder. This trick allows us to build chain by calling the next methods on our builder. And we have special method to terminate chain of invocations. This is build method. Build method returns us the reference to already built and constructed object. Let's look at the client code to understand how it works. I call new builder method, and after that I build chain of setters that I need. And this chain is terminated with build method. That's how I get my account object. This architecture allows me to build objects step by step and initialize only those properties of my future object that I need. Hope this example makes things clearer. Let's now come up with checklist to implement canonical builder and chain builder pattern. To implement builder pattern with director, we have to declare builder interface, create multiple builders, create directors that can work with different builders, in client code instantiate director and concrete implementation of builder to build new objects. To implement builder pattern with chain method calls, we have to create inner builder class inside type that we wanna build, implement method in type that returns reference to the builder object, declare setters in builder that returns the reference to this builder object, implement build method to terminate method chain and return target object. In client code, call method to get reference to builder and build object step by step. Basically, that's it regarding builder pattern. Let's move on. And the last but not the least pattern for today is an abstract factory. We need abstract factory for cases when we need to create a group of interdependent classes. By implementing abstract factory pattern, we define an interface for families of objects without specification of concrete class. To understand this pattern, let me explain you an example. Look at the class diagram that you see on the slide. Imagine that we are working on the desktop application and we need to create pop-up window that is specific for each operating system. I mean, on macOS we have close window button on the top left corner. In Microsoft Windows we have close button on top right corner. We have different styling of scrolls and buttons. That's why we have two abstract factories, for Microsoft Windows and for Mac OS. Each factory can build window that contains only objects that should be used together. So, in this task, when I create window, I need to create set of objects, buttons, scroll, content area, and so on. And I can create scroll for Windows and combine it with macOS buttons. Understand? That's why we can talk about family of objects that can work together with each other. I will pass my abstract factory to GUI builder so that GUI builder can use abstract factory to create all necessary elements for my window. Does it make sense? I can proceed explaining theory, but to be honest, personally for me, this pattern wasn't obvious until I saw a real-life example. So, let's jump to an example. Let's start our demo from abstract factory itself. Here is my abstract widget factory that declares three methods. Method that should create window itself, method that creates scroll, method that creates an array of navigation buttons. Can you recognize what these methods remind you? They look like factory methods, do they? This abstract factory and abstract methods here will be implemented for different families of objects. I have Mac OS widget factory and a MS widget factory. And you can see that in each class I create objects that should work well with each other. For Mac OS widget I create Mac OS window, Mac OS scroll and Mac OS buttons. For Microsoft Windows I create MS window, MS scroll and MS buttons. Does it make sense? Next, I have GUI builder. I can pass to it any concrete implementation of abstract factory I have, and GUI builder will use this API to build all necessary elements and display them properly. Now let me open my demo file. You can see that I create GUI builder, and after that, based on the user input or app configurations, it doesn't matter, I can take information about operating system from different places. But when I know operating system, I initialize my widget factory and call build window method by passing there my abstract factory. That is how abstract factory pattern helps us to deal with instantiation of family of objects. Now let's come up with a checklist that you need to follow when you want to implement abstract factory pattern. Implement class groups, also called type families. Declare abstract factory interface with factory method per product. Use abstract factory to instantiate group of related objects. Hope that now abstract factory pattern doesn't look like something scary. And before we call it a day, let's understand what is the difference between factory method and abstract factory. I would like to list few differences. They are: factory method focuses on generation of one single object, whereas abstract factory should solve issue of instantiating group of related objects. Factory method can be part of abstract factory, but also factory method can exist independently. When we are talking about factory method, we mean one method that can generate specific object. But when we are talking about abstract factory, we mean a type that may contain many different methods that help us to create group of objects. Factory method relies on inheritance mechanism. It allows subclasses to decide what implementation of specific type to generate. But in abstract factory, the main focus is on generating multiple objects from one family that are not connected within one hierarchy. Hope that visualization on the slide and my explanation helps you to understand the difference. Now let's recap what we have learned today. In this lesson we learned 5 creational GoF patterns. After this lesson, I believe you know Singleton, Prototype, Factory Method, Builder, and Abstract Factory patterns. That's it. Thanks a lot for your attention, dear students. See you in the next lesson.